In 1999, a joint venture between Lockheed Martin and NASA's JPL went viral for all the wrong reasons. So they created something called Mars Orbiter, which was supposed to explore the climatic conditions of Mars. So when they placed this orbiter into the orbit, things went south very fast. The trajectory of the orbit was off by hundreds of kilometers, and finally the $125 million probe disintegrated into thin air due to the Martian atmospheric friction. So why did that happen? One obvious reason is, of course, they tried, and the other one is the engineers in the Lockheed and the JPL didn't speak a common language. But of course, they were both in America. What I'm speaking about is the measurement units, right? The base reference quantities you use to represent a measurement. Lockheed used English measurements, or the inch feet for measuring length, and pounds for measuring force or weight, whereas NASA used meter for length and kilogram for mass and Newton for weight. So usually you need to do some kind of conversion, but that's when things all went bad, or at least that's how the fault and the lethargic organization within the NASA got translated into an actual error, which you can read more about it in the link in the description below. Alright, so I'm Anuj, and let's talk about units. I wasn't actually planning to start this video with a tragic event that happened decades ago, trust me, alright. I was actually planning to invite Johnny Depp in his Edward Scissorhand makeup to see how the conversation would go if he wanted to buy a table that's twice the size of his hand. Yeah. So, alright, so let's just imagine, okay, let's just say I wanted to buy a table that's twice the size of my hand. How would that conversation go? And I wanted to buy this table from someone that's 1,000 kilometers apart. How will he ever know what's the size of my hand? Is it like a baby hand in the T-Rex, or is it like that hand of the elastic guy in the Fantastic Four? No idea. So in order to give him an idea, I can send him my arm. Of course, not my arm, a prototype of my arm, something I made out of clay. Alright. So that would be fine, but let's just say he had like 1,000 customers all over the world, and everybody started sending him an arm. Alright. That would be a nightmare for him and for me, because he's gonna definitely switch the arms and gonna send me something else, a size I don't want. Alright. So one important thing to note here is that I'm using my hand length as the unit of length, right? And I want a table that's whose length is twice the size of my hand length. So you can see that the 2 is multiplied to the unit of length, which is the hand length, which is kind of the base reference quantity we have for measuring length. Yeah. So if I kind of, instead of 2 multiplied by hand length, if I just write 2 without the hand length, then the 2 has no meaning, right? It's just a number, mathematical value, that's all. So when I used my hand length as a unit for length, as a base reference quantity, it was very confusing, right? And similar kind of confusion happened between people when they try to measure length and wanted to communicate it with other people in the world. So they started using feet, and again, someone in some state would say, hey, this is the actual length of the feet, and another state would say, no, this is the actual length of the feet. So there was again a kind of standardization within states, but not outside the state. You can think something like that. So this called for even greater standards across the globe, and that's where SI unit comes in. So French, after the French Revolution, I guess, they kind of got this units defined, and it's also called the metric system of units. And now it's officially accepted by scientific community all over the world. Yeah. So whenever a scientist makes a measurement, or an engineer makes a measurement, he can use a metric system to communicate his value to his peers across the globe. So the feet, which is used for measuring length, belongs to English system of units, or imperial units. Alright. And if you take a look at the feet, it's pretty popular with the real estate people, and you can see that the carpet area, the house area are all represented mostly in square feet. Yeah. So just for sake of comparison, let's compare the metric system of units and the imperial system of units only in terms of length, okay, not in terms of weight or anything else, just in terms of length. If you see, metric system kind of is built on base 10, okay, so 10 millimeter makes 1 centimeter, 10 centimeter makes 1 decimeter, 10 decimeter makes 1 meter, and it goes on. But in case of a feet, 12 inches make 1 feet. So if I want to partition 1 feet into 3 distinct parts, I can simply take 4 inches of each part, right? Because 4 multiplied by 3 is equal to 12. So I can divide 12 inches into 3 parts, with each part being 4 inches wide, something like that. But in case of meters, if I want to divide it into 3 parts, it's going to be 3.333. That's a weird number. You can't actually measure in any scale. And if you round it to 3.3, then you're going to be left with 0.1 meters. I don't know what we can do with that. And why is that? Because if you kind of take a look at the factors or the divisors of the numbers, the base numbers, the metric has the base 10, so it has the factors 1, 2 and 5, whereas 12 has factors 1, 2, 3, 4 and 6. So 4 divides the 12 into 3 parts, whereas there is no such divisor for 10 which can divide it into 3 parts. So it kind of feels like metric system has no place for odd numbers or odd divisions. Even if you take a look at the scientific notation while approximating, if it's a 0.5, all right, I am approximating it to one's value, one's place. Then if it's an odd number, then I'm gonna increment it so that it's an even number, whole even number. Otherwise, I'm gonna just leave it at as it is, which is an even number. I don't know why there is a kind of preference to even than an odd, maybe. Another important thing about SI system of units is the prefixes. It kind of allows us to use prefixes for instead of numbers. So if you take a look at this value, right, 6,000 meters, you can also represent this as 6 kilometers. So which is easier to read, right? Instead of counting the number of zeros, it's pretty easy to read 6 kilometer, because we kind of have a preference to names than numbers. That's why we have names in alphabets, not in numerals or numbers. Alright, so if the number of zeros increases, say we have like 6 zeros, like 6 million meters, then we can use the mega, which means 6 megameters. So clearly the confusion that arises while reading the number of zeros is high than reading this value with the prefix on, right? But there is a catch. Not all numbers are gonna be perfectly ending in zeros with a lot of zeros. So what do we do in that case? That's where we approximate, right? So let's take this value for instance. We can approximate it to whichever the place value we feel okay with, like depending on your accuracy needs, because someone would represent this value as 6.1, all right, 6.1 kilometer. It's totally up to you. But again, if we approximate, we are going to lose the accuracy, and that's a catch. So if you are an accurate person, you might feel that the prefixes are kind of useless. That's just but for most of the time, approximates kind of works in public places where accuracy is not that much of an important, and yeah, prefixes do help there. Alright, so now that we have an idea about units and why we need them, and more importantly, why it should be standardized across the globe, now it's time to take a closer look into the SI units, alright, which I'll be doing an in depth review about it in the next video. So, until then, you can let me know in the comments below if you think that SI system of units is more biased to even numbers than the English system of units. And yeah, see you in the next video. And hey, if you want to read more about this in the form of blog, you can check out my blog, which should be visible on the screen, and the links are also in the description below.